Welcome to Brain Vision.
Let's find the differential of this given function. So note here that your u is a function of two variables. So let's go ahead and rewrite that u as u of x comma y. And then the formula for the differential, du, this is the differential of u. And on the right side, we'll have the partial derivative of u with respect to x times dx plus the partial derivative with respect to y dy. So we'll have to go ahead and find some partial derivatives here. To make that a little easier, let's just rewrite this as a rational power. So we can use the power rule with the chain rule. So we see here, take the first derivative with respect to x. 1/2 comes off to the front. So we're using the power rule right now. Subtract 1 from that power, so you get a minus 1/2. And then by the chain rule, you have to multiply by the derivative of the inside, which in our case is just 2x. So that gives us x over x squared plus 3y squared, all inside the radical on the bottom. And then similarly, we can do ui. So use the power rule and the chain rule together here. So we're differentiating this guy right here with respect to y. 1/2 comes off in front. We'll get that radical in the bottom again. And when you multiply by the derivative of the inside with respect to y, that'll be 6y. So that gives us 3y over the radical after we cancel. And now we'll just go back and plug all this in. So ux, we just found that down here. That'll give us x over the radical. And then you still have, don't forget your dx there, multiplication. And then for ui, we found that over here. Radical back in the bottom. And also here, we can't forget to multiply by the dy. So there it is. We have the differential notation du on the left-hand side, and then we use the formula to obtain the right-hand side. So that's our final answer.